this video, we are going to discuss finding the domain and range of a given graph or equation. So let's get started with the graphs. Remember that the domain is a set of x values that satisfy whatever we're looking at, and that's also going from left to right. So if you look here, it looks like we can have any x value that we would like from the left to the right. So the domain would be from negative infinity to positive infinity. You could also write that as all real numbers. The range, let's look at the range. That's from top to bottom, the y values. It appears that our range here is also negative infinity to positive infinity. Okay, so this one, even though it looks different, after using what we know about domain, being the x values and range being the y values, we concluded that the domain and range are both negative infinity to positive infinity. Let's look at this graph here. The domain starts at 0, and we can follow this, and the arrow lets us know that it's going to continue. So the domain would be from 0 to infinity. And I'll put a bracket with the 0 because it is included. Okay, the range is going to be from bottom to top. So if you notice, we don't start until 2. So our range would be from 2 to positive infinity. Okay, looking here, our domain from left to right, it looks like we can come this way from negative infinity, but we have to stop once we get to 3, and the 3 is included, so we put a bracket with it. The range, it looks like we can go from negative infinity, but we have to stop at 0. So it would be from negative infinity to 0, and we put a bracket with the 0 because it is included. Okay, let's look at this graph here. The domain, we can tell, is going to be negative infinity to positive infinity, because we can go as far left or right as we want to. But the range, it looks like we're getting close to 0 over here. So I'm going to put 0. I'm not sure if 0 is included, so I'm just going to leave it out. And go to infinity, because I can go as far up as I want, but it looks like I have to stop about 0 here. Okay, the domain here is going to be from negative infinity to positive infinity. The range, we can go from negative infinity up to 5. So it's going to be negative infinity to positive 5. And I put a bracket because that 5 is included there. Okay, this one's a little bit different. We have an asymptote that we can see, and we'll talk about asymptotes in a later video. But if you can see, the domain looks like it's anything except negative 2. And the same on this side. So the domain would be from negative infinity to negative 2, not included, union negative 2 to infinity. I did not include the negative 2 because it's not ever going to touch that. Okay, the range looks like anything, then we get to 0, that's left out. So it would be negative infinity to 0, union 0 to infinity, because it's not going to touch the y-axis here. So this would be the domain and range for this function. So it's pretty easy to find domain and range looking at a graph, but it's a little more difficult when we have an equation that we are working with. So here we have f of x equals negative 5x squared plus 4. This, if we know what those transformations to our paired function, which would be the quadratic, will do to our graph, this will help us when we have just the equation. So I'm going to draw a little sketch. I know this is reflect over the x-axis. It's going to be up 4, and it's going to be stretched. It's going to be skinnier. Okay, so let's keep that in mind. What's our domain going to be? It's going to be from negative infinity to positive infinity, because we can plug any real number in and we'll get a real number out. Our range is a little bit different though. Remember, this is 4 here. We can go from negative infinity all the way up to 4. So I'm going to say negative infinity to 4. I'm going to use a bracket because 4 is included. Okay, so this one is a little bit different here. we have g of x equals 3x cubed minus 15. We know that this is a cubic function, and that's the basic outline for a cubic function. We're not reflecting it, we moved it down. Okay, so let me redraw this. We moved it down about 15 places on the y-axis, which is good. But it still didn't change our basic shape. So our domain is going to be negative infinity to positive infinity, and so will our range. Okay, so cubic functions, this is the domain and range regardless of the transformations that we make. Okay, here we have h of x equals 1 over x minus 4. And we need to remember that we can't have 1 over 0. That doesn't work out. So the only thing that will make this denominator 0 is 4. So the domain will be from negative infinity to 4, union 4 to infinity, because that's the only way we get 0 in our denominator. Excuse me. Our range is going to be whatever can make this 0, or what happens when this is 0. So our range would be from negative infinity to 0, union 0 to infinity. Because we didn't move it up or down any, our range will stay the same as our parent graph if you watch my previous video. Okay, here we have a piecewise function, but if you notice, we have all x values accounted for. So I'm going to say that our domain is from negative infinity to positive infinity. And if we draw a little sketch of our graph here, we can know that y equals x is happening to about here. Then we have 2 going on right here, and then we have x squared going on somewhere in here. So we have all of our x values accounted for, but we also have all of our y values. So our range would also be negative infinity to positive infinity. Another way that you could write negative infinity to positive infinity, which means all real numbers, is you could write it as an R with 2 legs in the back. Okay? So domain and range, we did that from a graph and from an equation, but even when we were finding it from the equation, we were still thinking about the graph.